Hi all, this is Guided Practice 23. This is section 6.2 on trig functions of angles. We've got a couple of practice problems here. Some of them are similar to what we did in the lecture and some of them are just a slight adaptation. So number one's just a little bit different. So number one says find the exact values of the six trig functions of theta if the sine of theta equals 3/5. Now normally I tell you what this angle is going to be. Right? And I say, oh, take the sine of this angle. In this case, we're going the opposite. We're not given that information. All we're given is what the values are for that function, for that trig function. And for sine, we know that this is the opposite over the hypotenuse. So that tells me that 3 is going to be the opposite side, and the hypotenuse is going to be 5. So what that allows me to do is it allows me to draw a triangle. Generic triangle. Now, I don't know what this angle is, but I'm going to call it theta because that's what they described. But I do know that the opposite side, so the opposite that angle is 3, and the hypotenuse is 5. Okay. Now, I can find that third side using Pythagorean theorem. If you know your Pythagorean triples, that could be helpful here. You'd know that this is going to be 4, but we can find it by using our Pythagorean theorem. So let's call that a for a side length a. So in the Pythagorean theorem, we'd have a squared plus 3 squared equals 5 squared. Make sure that your hypotenuse is the one that's on all by itself. And this is going to be a squared plus 9 equals 25. Subtract your 9 from both sides. That's going to give you 16. And then take your square root. And I get a equals 4. Now note that I don't take the negative 4 because this is side lengths, and side lengths can't be negative. So we're going to let this a be 4. Okay, so I'm actually going to erase it and place the 4 there. So now I have my triangle with sides 3, 4, and 5. Okay, that's going to allow me to state what the 6 trig functions are. So we already have that the sine of theta is the opposite over hypotenuse. That's the 3 over the 5. Then the cosine of theta is the adjacent over the hypotenuse. So the side adjacent is this one down here. So that's going to give me 4 over the hypotenuse, which is 5. The tangent of my angle is the opposite over the adjacent. So the opposite side is the 3. The adjacent side is the 4. Okay. And then your other 3 are the reciprocals here. So cosecant theta is the reciprocal of the sine, right, or the hypotenuse over the opposite side, and that's going to be 5 over 3. The secant is the reciprocal for cosine. That's the hypotenuse divided by the adjacent side. The hypotenuse is 5. The adjacent side is 4. And then cotangent is the reciprocal of tangent. So that's the adjacent side, which is 4, over the opposite side, which is 3. And there's my 6 trig functions. Right, now this one is a little bit different. Instead of telling me what this trig function is, right, this is saying here's my angle measure, 3 pi over 4. What are the 6 trig functions? Okay, all right. So what we want to do is we want to think about what that converts to. So what does this convert to? So we have 3 pi over 4, and another one of our conversions, this is in radians. Another way to convert would be to take the number of radians in the bottom and the degrees on the top. And for radians, we have 2 pi, and for degrees, 360. You could also use pi and 180. All right, and so when you do that, you get 360 times 3. If we're just multiplying across, so 1080 pi over 8 pi. Your pi's will cancel out, and 1080 divided by 8 gives you 135. So we're finding the 6 trig functions of 135, okay? Now, 135 is bigger than 90 degrees, but smaller than 180. So that means I'm going to graph that into quadrant 2. So bigger than 90, smaller than 180 is in quadrant 2 over here. So I'm going to put that angle over here. And 135, 90 would go this far. So 135 minus 90 is 45. So this side is 45. But that means that this angle, which is the one that I care about, is also 45. Because 180 minus 35 is 45. That creates my triangle. Okay. Now remember, your all students take calculus or your cast, right? That tells me that only the sine and the cosecant are going to be positive. Everything else is going to be negative. And my reference angle is my 45, 45, 90. So we're thinking, okay, we've got 1, 1, and square root of 2. And I'm going to use that information to get all 6 of my trig functions. So the sine of 3 pi over 4. So sine is going to be positive. We know that because we're in the S quadrant. And the sine is opposite over hypotenuse, so 1 over root 2. Rationalize it to be root 2 over 2. Then cosine of 3 pi over 4. We want the adjacent side over the hypotenuse, so that's 1 over root 2. Or rationalize again to root 2 over 2. The tangent of 3 pi over 4 is now the opposite over the adjacent. So the opposite side is 1, so is the adjacent side, so we get 1. Now, be careful here. The first one, the sine was positive, but that's the only one that's positive. So cosine is going to be negative, and tangent is going to be negative. Okay. And then the other 6 are going to be the reciprocals here. So cosecant is 1 over the 1 over root 2, so that's just root 2. And that one's positive because that's sine's partner. Cosine's partner is the secant. So we can flip that one over and make it the root 2, but that one's negative. And then cotangent is the reciprocal of negative 1, which is just negative 1. And there are my 6 trig functions. Then we want the same thing, find the exact values of the 6 trig functions for theta equals pi. Okay, now pi, when I graph that one, is all the way over here. So this is on the axis. And to get that one, we use our unit circle. So our point on the circle here would be negative 1, 0, because that's how we would plot that point. And we know that the first coordinate is the cosine of x, and the second coordinate is the sine of x. Okay, so to get our 6 trig functions, the sine of pi would be the 0, because that's the second coordinate. The cosine of pi is the first coordinate, so negative 1. The tangent pi, we're going to use our identity here, and we know that tangent is the same as sine over cosine. So sine divided by cosine would be 0 divided by negative 1, and that's just 0. And then for the other 3, we take the reciprocal. So cosecant is the partner for sine. So cosecant of pi, we would take 1 over the 0, and that's undefined. Then we would have secant, which is the reciprocal of cosine. So 1 over negative 1 is still negative 1. And the cotangent of pi is going to be 1 over 0, negative 1 over 0, and that is also undefined. And we'll end there.